So now we want to look at three new trig ratios called the reciprocal ratios. And we know the primary ratios, sine, cosine, tan, are defined as shown with reference to the point of intersection where the terminal arm intersects a circle and the radius of that circle. So three new reciprocal ratios. The reciprocal of cosine we call secant, abbreviated like that, is r divided by x, so that's secant. This is what I'm saying. Reciprocal of sine is cosecant. Reciprocal ratio r over y, so that's cosecant. And the reciprocal of tangent is cotangent, abbreviated as so. And that's all there is to it. Remember, if you're dealing with a unit circle where the radius is 1, cosine sine are simply the x and y coordinates on the unit circle. Tangent is still the slope of the terminal arm, y over x. And so my reciprocal ratios would be, secant would just be 1 over x, the reciprocal of the x coordinate, cosecant, the reciprocal of the y coordinate, and cotangent, x over y. So in our first question, we want to find the exact value of the cotangent of negative 135 degrees. And let's just begin by drawing that out. 135 degrees measured counterclockwise would be approximately there. We have a circle drawn here, and our point of intersection is so, x comma y. And we know that the definition of cotangent is the reciprocal of tangent, so I could write this. Or I could write just simply x over y, which is the reciprocal of tan, which is y over x. So what I need to know are the x and y coordinates. I can use either a unit circle here or a non-unit circle. And the other thing to keep in mind is that we can't really use a calculator for this because it says to find an exact value, and a calculator is going to give us a decimal approximation. So we need to know this x and y coordinate. And we can do that because you'll notice that the reference angle, the angle rated here, is 45 degrees. And if we have a 45, 45, 90 triangle, we know that the sides are 1 and 1 and the square root of 2. And so I can work with this triangle. This length here, the radius, is root 2. This distance across is negative 1. And this distance down is negative 1. And so my x divided by my y would be negative 1 over negative 1, which is positive 1. Now it turns out that since the answer is 1, if we had simply typed this in to our calculator, it would have also have indicated that our answer was 1. But if the answer had involved a radical or something, we would have had to have used that to establish the exact value. Alright, here's another trig ratio, the cosecant of 7 pi over 6, which we can think of in a few ways. That's the reciprocal of sine. Sine is y over r, so this would be r over y. Or we could write it as 1 over the sine of 7 pi over 6. Alright, we're asked to find an exact value, so we have to draw this out to come up with the values. First thing we'll notice is that our angle is in radians because there's no degree sign. So 7 pi over 6, probably what most of us will want to do is convert that over to degrees by multiplying by 180 over pi. So that cancels out, the pi does. And so this is 210 degrees. So a positive 210 degree angle, 7 pi over 6 radians, is approximately there. And I'll notice that we have a reference angle of 30 degrees. And we know that 30 degrees is in the special triangle, 30, 60, 90, in which the sides are 1, 2, and root 3. So if I think of that angle, or that triangle, substituted into this little section, the distance across is negative root 3 because of where I'm at. It's negative 1, again because of where I'm at. And the radius is 2. Alright, so when it comes down to answering the question, the radius is 2 divided by the y-coordinate, which is -1, and so I get an answer of -2. Again, we have a question that doesn't have any radicals in it, so it turns out we could have just typed this into the calculator and got an exact value. Let's just show how to do that with the calculator. Alright, to enter cosecant of 7 pi over 6, I'm going to have to enter it in this form since I don't have a cosecant button on my calculator. The first thing I need to be mindful of is that my mode must be in radians. So the third one down needs to be in radians, which it is. And then I'm going to type 1 divided by the sine of 7 pi over 6, which is -2, which is what we got. But let me emphasize again that when you're finding exact values, usually you have to do it visually, not with the calculator, because most of the time your answer will come out to be some irrational decimal, which is not an exact value. For non-special angles, so angles which are not multiples or reference angles involving 0, 30, 45, 60, and 90, the only way to get the trig value then is to use the calculator. So if I have the sine of 1.92, okay, the sine of an angle, because this is always the position of where we put the angle, of 1.92, that's radians because there's no degree sign. So if I type sine of 1.92, decimal approximation is 0.93, let's say 0.94. Okay, and remember what this means. It means that if you had a unit circle and you had an angle of 1.92 radians, which would turn out to be somewhere in quadrant 2, remember that means that the arc length is 1.92 times the length of the radius. Then the sine value, which is the y-coordinate of the point of intersection, is 0.94. For the secant of 85.4 degrees, you'll notice that 85.4 degrees is not a special angle, and so we're going to need to use the calculator to come up with this ratio. So secant is the reciprocal of the cosine ratio. Right, so just a reminder of what we're finding in this question. If we had a unit circle and we had an angle of 85, which is almost at 90 there, okay, and we have this point of intersection x comma y, the value of secant is going to be the reciprocal of the x value, because the x value on the unit circle is cosine. So the answer we're getting here is going to be the reciprocal of this. Okay, so there's a lot of deep stuff going on here in terms of understanding and thinking. So the first thing we want to do is change our mode back to degree mode. You always need to be mindful that different questions can require you to be in different modes, so we're in degrees. And there's a couple of ways you can type this in. You could simply type cosine of 85.4, which is 0.08, which remember is the x-coordinate on the unit circle, very small, very close to 0. But we want the reciprocal of that, so we want the 1 over that. So I could use my reciprocal button, which is that, answer to the -1. The other way I could just type this in is simply 1 divided by cos 85.4 degrees. And out comes 12.47. Alright, the next thing we want to do is we want to be able to go in reverse. We want to be able to solve an equation for an angle where the ratio is given. So previously we were given the angle, we were finding a ratio. Now we're given the ratio and we want to find the angles involved. So we want to solve cotangent theta equals -2.777 over this interval. Okay, so there's a couple things to notice here. First of all, we're solving for theta, and this is telling us that theta is in radians because 0 and 2 pi doesn't have a degree sign, therefore it's assumed to be radians. First thing we need to do is convert this into a ratio we can work with on our calculator. This would be tangent. Tangent would be the reciprocal of this. And the question is telling us we want all the angles between 0 and 2 pi. Remember, 2 pi is like 360. And if we think back to the way we did this last year when we were working just with degrees, it's the same way. We have to ask ourselves, where is tangent, or what does tangent have a negative ratio? Where is the y divided by the x values negative? And that's in quadrants 2 and 4. There's one angle here, and there's one angle here. And you'll remember that what these two angles have in common is that they have the same reference angle. And so we get the reference angle by taking the inverse tangent, and remember that we take the inverse tangent of the positive ratio. The negative just tells us which quadrants we're dealing with. So on my calculator, I'm typing in inverse tan, because inverse gives the angle. Okay, let's just back up a moment. Now, we got to be careful because we are in radians, we said. So we got to convert our calculator over to radians, turn our calculator to radians, go to a blank screen, do inverse tangent of 1 divided by 2.777. And we will get a reference angle, 0.346. All right, let's calculate our standard position angles. In quadrant 2, theta is going to be 180, which is pi radians, minus the value of the reference angle. And in quadrant 4, theta is going to be 2 pi minus the value of the reference angle. Now the reference angle we have on our calculator. And what I'm going to do is, because I'm going to need to use this twice, I'm just going to store it in position, in position A. Okay, so now when I calculate pi minus the value in A, I'll go alpha A. The angle in quadrant 2 is 2.80 radians. And the angle in quadrant 4 is 2 pi minus the reference angle. Okay, and we got our two solutions between 0 and 2 pi radians. In our next example, we're being asked to give exact answers, which is usually an indication that we won't be able to use a calculator. Also, we'll notice that the ratio that's given involves numbers that appear on this special triangle. Okay, 1, 1, and root 2, which is a 45, 45, 90 degree triangle. Okay, so let's keep all this in mind. First thing we need to do is convert our ratio over to one of the trig, the primary functions. In this case, sine is the reciprocal of cosecant. We know that sine is negative in quadrants 3 or 4. And we also know, by the way, that this ratio can be written as so. And so if I think of the sine ratio, which is the y-coordinate divided by the radius, I can think of there being a 45 degree angle in each of these spots. If I just move my triangle over to those positions, and those reference angle positions, this would be -1 because of where I'm at, -1 and root 2. And over here we'd have +1, -1, and root 2. In both cases, though, the sine is the y of -1 over the radius of root 2. Also, our reference angle, instead of saying 45 degrees, we need to say pi over 4 because we're asked to give the angle in radians. So to come up with our final answer, we'll notice that theta has to be between -2 pi and pi. Let's first of all consider if there's any angles between 0 and pi. Positive angles measured counterclockwise, you'll notice that there are no angles between 0 and pi, so we don't need to worry about that. But there are some negative angles. There's the angle measured clockwise here, which is simply -45, or because we're doing radians, -pi over 4. And this angle here, which if we went all the way over to here would be -pi, and we're pi over 4 short of that, so we're at -3 pi over 4, which gives us our two answers.